All right, we're starting our very last unit, which is kind of a mini unit. There's only going to be 2 lessons with this, and we're going to try to get them both done this week, okay? It's trigonometry, and we're going to use trigonometry to find in right triangles, okay? So that's the first thing. Trigonometry, the primary trigonometry ratios that we're going to learn about in this unit are only work when you've got a right triangle, okay? So a triangle with a 90-degree angle. And this unit used to be part of the grade 9 curriculum a long time ago when I went to school, when I first started teaching, okay? So it's not very challenging. So I'm just letting you know that, because if you're tired right now, just keep going. This is a great unit. It's almost fun, okay? So the first thing that we're going to learn about is how to label the sides in a right triangle. And you guys already know this. You already know from grade 8 and grade 9 that the hypotenuse is the longest side length on a right triangle. Okay? And then on a right triangle, we're going to label the other 2 sides either adjacent or opposite. And it depends on the angle that you're looking at. For example, right here, we're looking at this angle right here. Okay? So another word for beside is the word adjacent, okay? If something's adjacent to something, it's beside, okay? So the hypotenuse will always be beside one of the angles that you're looking at, because it's always opposite the right angle. So if we're looking at this angle, the other side that's beside it is the adjacent side. And then look at, if we shoot a beam of light from that angle, that shoots at the opposite side, okay? So that's the most important thing that we're going to learn right now, is how to label the sides of a right triangle. Okay, and of course it's always relative to the given angle. That here, this little symbol right here is called theta. Okay, so here the hypotenuse is usually the easiest side to label. I'm just going to do hip. Okay, and then here if we use our beam of light, that's the opposite. And then beside it is the adjacent side, okay? In this triangle right here, we've got, this will be our hypotenuse, because it's always opposite the right angle and it's always longest. Here, for me, for whatever reason, I find the opposite side easier to label than the adjacent side, okay? So the hypotenuse is always the easiest one, and then I just think of the beam of light shooting out at the opposite side, and then of course the remaining side is the adjacent side, okay? Here, the other important thing to remember when you're doing trigonometry, for most other calculations, the mode that you're in doesn't matter, but for trigonometry, it definitely matters. So on your TI, hit the mode button, and then 3 rows down, see how degree is highlighted? That's what I want, okay? You will use radians in your 30 level math, okay, when you're wondering when you're going to use those. But for our course and for your 20 level courses, you'll always want to be in degree mode. But when you reset the calculator, it goes to radian mode. So just always double check that you're in degree mode if you're getting wrong answers, okay? Or before you're doing an assessment. And then to get out of that, we can hit second function mode to quit. Okay, so calculate the ratio of the opposite side to the adjacent side for each similar triangle. So here, we're going to label our sides first. We know this is our hypotenuse, this is our opposite according to this angle, and this is our adjacent. So then now, if we do the ratio of the opposite side to our adjacent side, that would be 1/2. Okay, here this is our opposite, this is our adjacent, so this would be 2/4, and of course we always reduce our triangles, so that would simplify to 1/2. And then this one would be, this is our opposite, this is our adjacent, so this would be 4/8, which simplifies to 1/2. So these all have the same ratio. They're all equal, right? So these are all similar figures, which you did in Math 9 as well. So that means that here, look at, to go from this to this, we doubled it, 2 to 4, and we did the same thing here, because as long as you're doing the same thing to the corresponding sides of a figure, then they're similar figures. So for example, to go from here to here, we multiplied by 4, 2 times 4 is 8, and that's what we did here, 1 times 4 is 4. Okay, so these are all similar figures because all the sides have been multiplied by the same thing to get the new sides. And look at the ratio of the opposite to the adjacent is the same as well. Okay, and what we've just looked at is the tangent ratio. So for trigonometry, we have 3 ratios that we remember by SOHCAHTOA, and we're going to start with this one right here. So this is your tangent ratio. So we would say the tangent of theta is equal to the opposite side over the adjacent side, okay? And you have your 3 trigonomic ratios on your calculator. So right here, sine, cosine, and tangent, okay? You'll notice up here is the sine to the -1, cosine to the -1, tangent. So we get that by going second function that button. And that's what we use when we're trying to figure out the angle, okay? Using a trigonomic ratio, because trigonometry can help us find a missing side length or a missing angle, depending on the situation that we're in, okay? So that's the first thing, so SOHCAHTOA. So TOA is tangent is equal to opposite over adjacent. And while we're here, we'll talk about this one is sine of theta, and I should put the E in there, is equal to opposite over hypotenuse. Okay, that's the SOH, and then cosine of theta is equal to adjacent over hypotenuse. Okay, so in a right triangle, if we just keep the angles, like for example, if we look at this, we know that this is 90. We know that all 3 angles in a triangle have to add up to 180. So if this is already taking up 90 degrees out of those 180, we know that these 2 angles have to have a sum of 80. So for example, this could be, or 90, sorry. This could be 1, this could be 89, because that adds up to 90. Or this could be 2, and this could be 88. And for that reason, if we keep our angles at whole numbers, then there's basically 89 different situations that you can have for right triangles when you compare the angles, okay? And that's why trigonometry was something that they were able to figure out really early on. Okay, let's keep going. It says calculate the ratio of the opposite side to the hypotenuse. So we just talked about that. We know that opposite to hypotenuse is sine. Okay, so we can write that sine of theta again is opposite over hypotenuse. So here, this is our opposite, this is our hypotenuse. So then that'll be 2 over 5. Here, according to this angle, so you always label your sides according to the given angle or the reference angle. This is your opposite, this is your adjacent, or sorry, hypotenuse. I'm still on the last page. Okay, so then we know that 4 over 10 reduces to 2 over 5. Here, this is our opposite, this is our hypotenuse, and 8 over 20, if we divide out 4 from each of them, equals 2 over 5. Okay, and then we do that third situation is calculate the ratio of the adjacent side to the hypotenuse. So that is cosine of theta is adjacent over hypotenuse. And so here, this is our hypotenuse because it's opposite our right angle. This is our adjacent side because it's beside our angle that we're working with. So this will be 3 over 4. Here, 6 over 8 reduces to 3 over 4. And here, 12 over 16. If we divide out 4 from both of them, we get 3 over 4. Okay, so what is a useful memorization tool to remember them? You never have to memorize them. They'll always be given to you on your formula sheet. But sometimes it's easier if we have them memorized. Okay, I'm going to stop here. And no, we'll keep going here. Let's see what we can get done. All right, so example 1. It says for each triangle, calculate each trigonomic ratio. So our first step 1 is always label your sides according to the angle you're working with. So this is our angle that we're working with. This is our hypotenuse. This is our opposite, and this is our adjacent. So for sine, we know that that's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we do here, this is going to be 4 over 5. This is going to be 3 over 5. and this is going to be 4/3. And it's okay if you have an improper fraction with your numerator bigger than your denominator. Okay, if we go in here, this is our opposite, this is our hypotenuse, this is our adjacent, so sine is opposite over hypotenuse. This is a prime number, so we can't reduce it. Cosine is adjacent over hypotenuse. And again, that prime number doesn't allow us to reduce. And then tangent is opposite over adjacent. And we can't reduce that one either. Okay, here we go. Here's our hypotenuse. This is our opposite. This is our adjacent. Okay, so sine is opposite over hypotenuse. So it's important to remember that because the hypotenuse is always the biggest side on a right triangle, your sine and your cosine ratios will always be proper fractions, meaning your numerator will be smaller than your denominator. Okay, but then for tangent, it depends. Cosine is adjacent over hypotenuse. And we don't put units because it's just a ratio. And then tangent is opposite over adjacent. So TOA, opposite over adjacent. And we can't divide that one out either. If this was 64, we could. All right, let's do this last one. Here, this is our opposite. This is our hypotenuse, and this is our adjacent. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And of course, you'd always reduce. Okay, that's it. We should be pretty comfortable now with labeling the sides of a triangle and writing out the corresponding primary trigonomic ratios. So sine, cosine, or tangent.